Sing. Remember to talk into the top of it.
Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Cafe.
Good evening, everybody. Thank you all for coming to our cafe tonight, The Beauty and Biology of Nature Sounds. My name is Catherine Fromson. I'm the coordinator of youth programs here at the museum, and in my free time, what little of it there is, I'm also a musician with the Raleigh Civic Symphony Chamber Orchestra. So tonight's cafe is actually part of a series of events that are leading up to a really wonderful concert this coming Sunday, which we hope you'll be able to join us for. There are flyers on your table with a little bit more information, and even better than that, we have Peter Askim, who is the conductor of the NC State Orchestras, and he's going to tell you a little bit more about Sunday's concert.
It's great to be here and to see such a great crowd. The events that Catherine is talking about are incredibly exciting to us and to the orchestra. We have lots of events that are kind of, I think of it kind of like a super collider, colliding science and art together, and that's what you'll see tonight, and that's what you'll see if you come to the concert on Sunday. So on Sunday, we have a concert at 4 o'clock featuring the music of Richard Blackford, who you'll hear speak tonight, and there's a new piece of mine as well that's on the concert. That will be preceded by what we call a sustainability showcase in the lobby at 3 o'clock, where graduate, undergraduate, faculty, researchers, and local organizations have displays, and we'll be talking about their research and their missions and the work that they're doing. The concert will be at 4 o'clock on the NC State campus in Stewart Theater, which is in the brand new Talley Student Union. It's a beautiful place. There should be a great crowd and a really interesting intersection of the arts and sciences. After the concert, immediately we'll have a panel discussion with 2 musicians and 2 scientists. I guess it's sort of like Survivor, the arts, right? We'll have, it'll be moderated by Larry Nielsen, who's the former provost and a really interesting guy. It should be a fantastic discussion, wide-ranging, covering lots of topics in both science and the arts and the intersection. So hope to see you there and enjoy tonight, and back to Catherine. Thank you.
Thanks. So we're very lucky tonight to have 2 speakers for our cafe. We have Daniel Fergus, who works here in the museum in our genomics lab, and you may recognize him from the face mite study that he's been doing. One of his particular areas of interest is the acoustic communication that fish and crickets do, and he's going to tell us a little bit more about the timing of animal noises, why they make the noises at the specific times that they do. And then after we hear from him, we're going to turn the stage over to Richard Blackford, who is the actual composer of the Great Animal Orchestra, as well as, here's my list, 2 musicals, 4 operas, and scores for over 200 films. So clearly he stays pretty busy. And he's going to tell us a little bit about the connection between science and music and how he incorporated nature sounds into this work of art. So, it's going to be a fabulous program tonight. We're bringing together different disciplines. We hope that you'll enjoy. We also hope that you will help us out with some survey research. There are surveys and pencils on your table, and our partners at NC State are very anxious to hear your thoughts, so please help us out with that. And let's turn things over to Dr. Dan Fergus. Here we go.
Hello, thank you. Is that up enough? So I'm going to try and be brief. I want Richard Blackford to have ample time. But I just want to talk to you a little bit about timing and animal communication, and I'm going to use as examples a couple of different systems I've used. One is this cricket. So this cricket here is it's a little smaller than that. It's about 1 centimeter long, and it lives in Hawaii, and it's or there, and it's this genus of cricket called Lapala, and it's the second fastest known evolution in invertebrates. So in Hawaii, there's 28 species of this cricket, and they're amazing. Love them. What's particularly neat about them is they're very hard to tell apart, hard for us to tell apart. There's a couple things that distinguish them, and one of them is their song. I think most of you know that crickets make songs. Do people know how they make songs? Rubbing their wings, exactly. So I have to show this. Oh, it's already started. So this is a high-speed video of one of our crickets making a song, and it has a file on one wing and a scraper on the other, and every time it closes its wing, it makes a sound pulse. And now it's turning and walking away. Sound. No? Another one? Come on. Sound! So these crickets are great. What distinguishes the species is how rapidly they make those sound pulses. So they're all about the same size. They all have about the same size wings. They all close them at about the same rate. But one of them goes close, pause, 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 close, pause, pause, pause. The other one goes close, 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 close. Which means they all sound like this. Or, and we have spectrogram. Oh, we don't, because I go the wrong way. There we go. If you look at the spectrogram of them, so a spectrogram, I think Mr. Blackford's going to explain a spectrogram a little better than I will, but the spectrogram shows the sound intensity with frequency on one axis and time on the other axis. So every pulse on this sounds like this, which is about 5 kilohertz. And what's neat is because there's so many species and they're all on Hawaii on this little island, if you overlap, it's hard to distinguish your sound from somebody else's sound, right? So if somebody was up here and sounded exactly like me, it's hard to tell us apart. So we also noticed, so that was one thing that was kind of interesting. The other thing we noticed is we'd go to a place where there might be 3 of these crickets, 3 of these crickets overlapping. And we'd go one day and we'd be like, oh, there's a lot of Paranigra here. And then we'd go the next day and be like, oh, there's a lot of Saracena here. I thought there was a lot of Paranigra. So I got to wondering if maybe they're divvying up the time by day. And so I went out to the field with a microphone and measured throughout the day and found that at different times of day, the different crickets are singing, so that maybe they are able to hear one another. And it's interesting to me because, so another cool aspect of these crickets, their courtship and mating lasts 8 hours. So you need to sing early, attract a mate early, but you still need to divvy up your day. And so then I went to another spot where there's only one species and looked at that spot and found out they sing all day long. So it's this neat system where when you overlap, you need to modify when you're singing. And so, I don't know where to conclude with that, but the other one is this fish species. So this is a fish called the plain-finned midshipman. It's a type of toadfish, which apparently we have toadfish experts in the audience. And this is the system I really love. So these fish, this is obviously just a cartoon, but these fish sing. Did anyone know fish make sound? Yeah? Did anyone know fish hear? Anyone surprised to know fish hear? If you go out with a fisherman or a fisherwoman, they'll tell you, be quiet. You're going to scare the fish. So fish hear very well. And some fish, a lot of fish make sounds. And this fish makes several different sounds, which I think I have a video of. That's aggressive. That means stay away. And that's a love song. It's nice, right? Get away. Stay away. Come here. So, this fish is great. So if you're interested in timing of animal communication, which I'm intensely interested in, and the genetics of timing, this fish is a great model. So they only make this, which I'm very good at doing. They only make this, fish just come to me. They only make that song in the summer at night, which is when, so that's a male right there doing that song. He digs a nest. That's what he's got there. He's got a nest, the one on the bottom, that he dug out under a rock, and he hums that hum, and the female hears it, and she comes in and she lays the eggs, and then she takes off, and he fertilizes them and watches them and takes care of them. There are sneaker males who sneak in and fertilize some of those eggs, but, oh, I didn't mean to do that. Anyhow, you'll get to hear it again. Stay away. Come back here. Sorry. Oh. And come hither. So this is cool. We're starting to look at the genetics behind and the molecular mechanisms behind why they only sing at these times. And it turns out if we stick an electrode in their brain, we can make them sing. It sounds awful. It's not so awful. We can make them sing, but the best time to make them sing is in the summer at night. They don't sing well other times. So we're starting to look at what's going on in their brain, what genes are expressed that make them sing at that time. But what's really cool, well, and I say it's really cool because it's what I'm studying, is their hearing. So fish hear very well, and these fish, the females of this species, of the plain-finned midshipman, if you play a song from a speaker, this to a summer gravid female, so a female who's ready to lay eggs, she goes nuts to that speaker. She tries to get into that speaker. If you play the song to a winter female, she doesn't respond. And you might think that makes some sense, but if you stick an electrode in their ear and try to measure their hearing, they just don't hear the song as well in the winter as in the summer. Unless you give them estrogen, and then their hearing shoots up. And this is really cool because humans, well, it's cool in its own right, but in humans, women tend to have better high-frequency hearing than men, until they hit menopause, at which point it goes down, unless you give them estrogen, at which point that high-frequency hearing stays up. So we know that in humans and in fish and in mice and in some other models, that estrogen strongly affects our hearing. Same with like monthly cycling, there's effects on hearing. And testosterone, so estrogen has a positive effect. Testosterone tends to have a negative effect on sound and sound processing. Aldosterone, another corticosteroid, has a strong effect. And why I thought this was interesting and a nice segue hopefully into what Richard Blackford is going to talk about is that when we go out and we listen to sounds in nature, the time of day that we go out really matters. And so it matters with those crickets, right? So if I go out in the morning, I might hear one cricket. If I go out at night, I might hear another cricket. But not only that, not only is the sounds that are produced affected by the timing, but how I perceive those sounds and how I process those sounds is strongly affected by timing on various scales. So seasonal, daily, with melatonin cycling. If we've been under a stressful situation, our hearing tends to go down a little bit. So there's a lot of things that affect the sound, our perception of the soundscape around us, both external, the soundscape itself, and internal. And so with that, I will hand it over to Richard.
Well, it's a great pleasure to be here. I'm slightly concerned. I've got various sources of things that I want to show and play to you, and I'm hoping by magic they're all going to happen. So the first thing I want to do is just come out of there. There we go. As Catherine said in my introduction, my experience over the last 30, 40 years has been as a composer of music for the concert hall and also a great deal of film music. On quite a few of those occasions when I've been working with the director, they've not only hired me as composer, but they've asked me to be sound designer as well. And always, I think it's one of the themes that is common to our evening that Dr. Fergus was talking about, is the theme of learning to listen with new ears, to actually go into an acoustic environment and be aware of the richness of the sounds that we're actually hearing. So quite often I'd be involved. I remember a film I did in Japan where I had to sample a Japanese fan and morph it into a flute sound or a burning, whatever it might be, a burning candle, and make percussion come out of it. And so I think that's quite an important thread as to how I came to work with Dr. Bernie Krause and how I've just flown from London to come for this performance of the Great Animal Orchestra, which Peter's about to conduct on Sunday. So tonight, I think I'd like to talk to you about the relationship of music and sound and how often that can be very blurred. How is it actually done? In a film, very often we use a sampling keyboard, whereby you can take literally any sound. I'm sure you're aware of this. You can put it on, you can assign a particular sound onto a key, you can play it with pinpoint accuracy and slot it in either live, playing it in live with an orchestra, into a film score, or you can just line it up on your computer in post-production and add it to the score. So you have the potential of, and we have done for years and years, of being able to add natural sounds to musical sounds. And when I started to work with Bernie Krause back in 2013 and put the idea to him, shall we try to create a symphony incorporating natural sounds, the sounds that he had recorded over some 40 years. He has about 5,000 hours worth of natural sounds recorded, from rainforests to sounds of birds in the air to underwater animals, to creatures in the desert, to insects. And as, of course, the years have gone on, the way of recording them have grown dramatically, from having to take huge batteries into the jungle, which would only last kind of an hour before you had to ditch them and go and find another one, to nowadays where you can take a solar-powered microphone, leave it on a plant or on a tree, and go away for 2 weeks and come back and then process all of your recordings, which of course don't have then any interference of humankind. So the recording possibilities are incredible. And Bernie, who lives in San Francisco, is one of the greatest exponents of and collectors of natural sounds. Where it all started, I listened to a serialized version of his book, The Great Animal Orchestra, which I realize I've just left on the table, which I'm going to need because I'm going to read you a little bit. Are any of you familiar with The Great Animal Orchestra? None at all. Oh, my friend's there. I heartily recommend it. It's available. It became a bestseller in the UK, and then it was not dramatized, it was serialized. And I heard Bernie talk about the way, the number of things, the way in which the natural world organizes itself into niches, into actual levels of sound. And I'm going to show you in a moment how he does that. He invented a word called biophony. And biophony is the sound that's made by animals and plants. He invented 3 expressions, and they have been adopted now by scientists all over the world. Biophony, the sounds produced by animals and plants. Geophony, the sounds produced by natural sound like wind, rain and water. And anthropophony, sounds generated by humans. And so those 3 categories, as a musician, I found extremely interesting, but it was biophony, the sounds created by the natural world, that I decided that I would explore. Many composers back from the 17th century have tried to imitate animals in sound. There's a wonderful piece by the French composer Jean Akin in the 17th century called Le Chant des Oiseaux, the Song of Birds. The great 20th century composer Olivier Messiaen wrote many hours of music in which he notated or tried to notate bird sound, and it's been tried from the time of Beethoven through the classical era right up to our own age. But one of the things that I believe we did, which had not been done before, in the past, composers spotlit a particular animal and said, this composition is about this bird, or about that mammal, or about that whale, or whatever it might be. And Bernie Krause had literally a nightmare, which was, I'm going to read to you from his book, where he talked about decontextualizing these sounds. And this got to be one of the most important things he asked me to agree to, not to just be seduced by what he called a trophy sound, a trophy animal sound, and say, there it is, let's combine it with some instruments, but to actually recreate entire environments out of music. Let me read a little bit from his book. I spoke to him this morning. He sends his regards and wishes he could be here, but he's doing a huge installation in Paris with soundscapes. So I feel it's my duty to let his voice be heard as well as mine. So he writes, a while back when I was cataloguing my analog tape recordings and transferring them into digital formats, I had a dream about sound, actually a nightmare. In the dream, I went to my lab at dawn and found that all of my ambient recordings had been transferred to thousands of little CDs, each with only one short clip of a single animal voice removed from the context of the soundscape. It's extremely difficult to recreate those choral expressions from their separate abstract parts unless we're able to grasp the underlying infrastructure characterizing how each component voice fits within an ever-changing bioacoustic composition. The decontextualized single-species model these scientists established ushered in a narrow academic recording format still favored nearly 8 decades later. For humans, the sound fragment model distorts a sense of what is wild by giving us an incomplete perspective of the living landscape. The soundscape's value as a window into ecological and musical literacy first became obvious to me while I was recording in the equatorial forests of Africa, Latin America, and Asia. Bored with chasing individual species and hearing single-channel monaural playbacks, I allowed the music producer training in me to surface, and I set up a pair of stereo microphones and hunkered down. As night fell, I felt enchanted and blessed to be enveloped in that world of 3D sound. The captured ambiances, rich textures that infuse the entire frequency spectrum with elegant structures, multiple tempi, and soloists intensified my experience of the habitat through their luxurious and subtle nuances. They were generated as points of sound transported through the acoustic space. For me, listening with open ears enhanced a sense of extraordinary humility and imparted a sacred gift. A souvenir of living sound from a distinct place at a moment in time. Even now, it brings me the greatest satisfaction, I know. So why don't you all treat yourselves and go buy a copy? There's a whole lot more great stuff in there. So I spoke on Skype with Bernie, and he said, I think you better come over to San Francisco and let's see if we can collaborate on a symphony. And he played me at least 150 samples, of which I chose 60 to be incorporated in a 5-movement symphonic structure. I'm going to just see where we are on this. Oh yeah, this is a quote from a Russian composer who I admire, Alfred Schnittke. One of my life's goals is to overcome the gap between E, Ernstmusik, or serious music, and U, Unterhaltungsmusik, or music for entertainment. Well, substitute serious music for science and Unterhaltungsmusik for entertainment, which is the art. I had to try to balance some kind of integrity to Bernie's vision, which you've just heard a little bit about, with writing a piece that would also be fun, that would be good to listen to, I hope good to play, you'll discover on Sunday if it is, and would hang together as a musical structure. So we're going to actually, I hope, be able to hear a little bit of the symphony. Here is a spectrogram. Dr. Fergus was just talking a little bit about the value of spectrograms. When I went to see Bernie, one of the things that he did was not only play me incredible things which I've heard in my life before, but he actually showed me what they looked like on a spectrogram. You're going to be wondering why this one looks like somebody's tooth that's just been extracted, and I'll explain that in a moment to you. What you actually see here is at the very top of the sonic spectrum, the sound of bats. This is a Borneo rainforest, and the bat frequencies are so high that you simply can't hear them, but you can see them. But below that, you start to see crickets, cicadas. Below that, you see a level which is birds. And that very jagged line, which is the deep yellow one, is the sounds of gibbons, pairs of gibbons serenading each other in the early morning. Have any of you ever heard the sound of gibbons? It's an incredible sound. It's absolutely phenomenal. I heard that on the radio broadcast with the BBC, and I thought, I've got to get involved with gibbons. I need a gibbon in my life. And so anyway, I started then to write the symphony. It may be a little bit difficult for you to see on the page there, but at the very top, on the left-hand side page, you'll see high instruments, wind instruments. In the center, there's horns and trombones. At the very bottom, you'll see contrabassoons and double basses. So I was trying to do graphically what Bernie was doing in his analysis of his recordings. And he said these spectrograms are just like a musical score, with the highest instruments, highest frequencies at the top, and the lowest at the bottom. And as a musician, I found that just a compelling idea. So the other thing about it was he said there are many tempi going on at the same time. Even now, virtually no study has been made of the multi-tempo layers of the animal world. We know that they organize themselves in niches because we can see that, and there are also very good reasons that they do that. To be able to be heard as an animal is not only a sense of, this is my song, I want you to listen to it, it's about survival as well. It's about survival and mating, and I'll come to that a little bit later on. But the multi-tempo aspect of it is also fascinating. Are they aware of the pulses that they create? Are they aware that one tempo is faster or slower than somebody else's? Here's a piano sonata that I've just been working on recently, which takes that idea in music. On the bottom stave, you can see one tempo going on in the upper hand, and then just below that a different tempo, and then beats at the very bottom which are marking a different kind of tempo. So I'm afraid once bitten by the bug of the Great Animal Orchestra, it's now starting to permeate other things that I have been working on as well. The first page of the score then starts with this tooth that you just saw, and we decided to introduce the idea of the sonic spectrogram of a Borneo rainforest. And for the conductor, he needs to have an idea of what's going on in the score. So I had to develop a graphic representation of what was going on the tapes. So it starts with high insects, birds, after 23-second gibbons, various calls, 7 regular descending whoops, short whoops, and after 3 short whoops, the conductor goes boom, and the orchestra comes in for the first time. And then the orchestra does what we've been hearing in terms of the natural soundscape. It starts with the highest pitches, and then little by little, the other instruments of the orchestra are introduced, and it's like a giant tuning up. Now, I'm hoping that I can play this to you, but I'm not quite sure. Let's have a look. If I do this, yes. And I think I just press play. Sorry, it's a little bit distorted, but I hope you could get the idea, and you could actually hear that as the orchestra was actually being introduced, there were a couple of gibbons who were saying, "Woo, what's going on here?" And then they're singing along actually with the symphony orchestra. Another of the themes that appealed to me a lot was about communication in the natural world. Dan Fergus was talking just now about the mating of the crickets. So mating play was a really important aspect of the animal world, and danger. And one of the things that Bernie played me was a chorus of Pacific tree frogs. He told me a fantastically interesting story. I said, why do frogs actually make that extraordinary stridulating sound in blocks? Why do they actually make a texture where each frog is indiscernible? And he said they do it entirely for survival, because while they exist as a chorus of frogs, no predator can actually tell one individual from another. And then he told me an extraordinary story. He was recording them one evening out at his place in Sonoma, just outside San Francisco, and he said as he was recording them, an aeroplane went overhead like 20,000 feet, but just enough for some of the frogs to be distracted from their song. And so they either looked up or they stopped, and at that point certain individual frogs could be made out, and an owl swooped down and got one. So fascinating that something as sophisticated as a chorus of frogs actually has a kind of Darwinian survival purpose. So the second movement of the Great Animal Orchestra, and which I'm hoping that we can do, is starts with frogs, and with this wonderful machine, the sampling keyboard, I was able to sample even one particular frog calling to another. So on one key you've got one frog going eh, on the other one it's going ah, like that. So as he plays the keyboard, he's literally going eh, oh, ah, oh, ah, oh, ah, oh, like that, but in perfect tempo. And that means that after a couple of bars of that, I'm able to add wood blocks and other percussion instruments, and to actually start to make an orchestral kind of rhythm section. So I'll play you the beginning of the second movement. We were a little bit distorted, Dan. Oh, it should be okay now. Let's see what happens. Am I on the second movement? Yeah, I think I am. Should we see what happens? Oh, no, no. So the second, how do I go down? To the, I click on it, okay. Okay. We actually have to click on it, I think, to try that. Yeah. A bit louder. Yeah. Oh, I see that one. Okay. Yes. Okay. And can you hear very well? It's not too easy, but maybe you could hear a little bit of it. You just have to come along on Sunday to hear it for real. So in that there was a woodpecker, and again it was a gift to a composer because the woodpecker was going like that, and I was thinking that is 144 BPM, so the piece has to go to 144 BPM in order for the woodpecker to be in time. And so we had so much fun actually transcribing and turning into musical notation these animal sounds. I just want to, if I can, come out of this. Show you some more spectrograms. This is a humpback whale, incredibly beautiful thing. It's like a piece of contemporary art. These are wolves, and in the third movement, I listened to wolves and I discovered that the wolves howl in close harmony, almost like a barbershop quartet. It's unbelievable. And do they actually know the pitches? We simply have no idea. And so I added to the wolves a pack of French horns so that sometimes you can't hear what's wolf or what's French horn. I won't play it to you now, but it's an extraordinary, eerie, blood-curdling sound, and it was just fascinating. This is my favorite. This is a thing called a musician wren, and it really is the star of the Great Animal Orchestra, though I promised not to do any spotlight on individual animals. This one really has to take a prize. The musician wren comes from the Amazon, and it has a 44-note song. And it gets to the end of 44 notes, and it goes back to the beginning again, and it does the same 44 notes again. And then after that it does it again. In the recording that Bernie played me, something hilarious happened, which is that she sang the song 4 times, absolutely the same 44 notes each time, and then a nearby parrot decided it had had enough. So the parrot goes, wah, 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 as if to say, enough, give us something else. And then the bird stops, and it goes for a moment, no song at all, and then it starts again, 44 notes. Well, to me as a musician, that's exactly what happens in a concerto, in Beethoven's 4th piano concerto. That's exactly the same trick. The piano plays something, the orchestra interrupts it, the piano says, no, 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 it's my tune. The orchestra interrupts. You have that play of one element with the other. And I found exactly the same thing going on in the natural world. So in the Great Animal Orchestra, instead of a parrot, which is not very musical, or this one wasn't very musical, there's another beautiful instrument called, a bird called a common patoo. It looks like something with a bad hairdo. It's the most extraordinary looking creature. But it sings a perfect 5-note scale, pentatonic scale, and the whole question of how humans have mimicked or imitated animals, especially birds. You can see if you go to Peru and get an ocarina, the ocarina is tuned exactly to the same 5 notes as the common patu, which is where it comes from. So instead of the parrot interrupting our musician wren, it was the common patu. So the last thing I'd like to play you, if I can manage it, tab, is the opening of the 5th movement with the musician wren, and you'll hear this extraordinary song, which I then ask the clarinet to play, and then the rest of the orchestra takes it up. So I notated it. Fingers crossed. No, have to press that one. Yes, that's it. Then now it's fine. Yeah. Yep. Piccolo. You'll hear the original in a moment. Common patu. And then the movement takes off, and there's a whole load of variations that go with that. So not only can we actually sample and play in time, we can play in tune as well. And the trombonist, not easy for him, has to actually play with a sample of a common patu, probably an experience he's never had before and will never have again. Anyway, I hope that's given you a little bit of a glimpse as to how this strange piece came to be written. It was one of those joyous collaborations by Skype, and Bernie Krause came to stay with me in London. I came over several times to San Francisco. And as the whole thing just evolved, it became a really joyous exploration of sound. And if nothing else, he really has been something of a mentor to me. He's really taught me to listen in a completely different way. One of the first things he said was, Richard, you can't just be an armchair composer on this. You have to get yourself out into the field. So I went off to Borneo, to the rainforest, and it was unbelievable. And if you ever get a chance, it really was a symphony of sound. If you ever get a chance to hear a rich, natural soundscape, I urge you to take it. Thank you very much.
There we go. We're going to take questions for both of these fabulous gentlemen. So let's kick it off. Katie and I will, if you raise your hand, Katie and I will come around to you. And Dan, why don't you go ahead and get us started?
So, my mic is... Hello? So my mic is on. I'm curious, so I'm a scientist. I'm curious the technical aspects. So you have on the keyboard, each key representing a different sound, basically an animal sound. Are you pulling that from the soundscape and sort of narrowing in and cleaning it up, or were you getting those from individual animal recordings?
Okay, a good question. And so we did both. Some things, like the Borneo rainforest, you press a key and out comes a whole rainforest, and that can last for as many minutes as you want it to last. Other things, like the frogs, by using the spectrogram, you can actually lasso a certain frequency, and as you say, you can even clean it up, and then that can be assigned to a particular note, so that a G sharp is not a G sharp, it's a frog, and F is a woodpecker. So it was a combination of the two things, creating entire environments and also spotlighting individual creatures.
The most important question to me is, how can we get tickets to go hear it?
They're actually available online through Arts NC State. If you go to the music department website, you can eventually get there, or I guess it's called Ticket Central. And you can also get them at the door, but I encourage you, if you're able, to get them ahead of time, because I think there's going to be a stampede of elephants going for those tickets.
I do hope you can come, and also the CD is available on Amazon. If you simply go to type in the Great Animal Orchestra, and it's a beautiful CD. I can say that because I didn't conduct it, but it's a lot of fun.
So for the orchestra and for other types of music that you present, do you, when you apply these sounds to a keyboard, right, to a synthesizer, do you ever modulate the sounds, or is it all essentially raw, natural sounds? Do you change the pitch or anything like that, or is everything as pure as it sounds when it was originally recorded?
We decided to do it absolutely pure, because apart from the fact of literally isolating things so that they were clearer to hear, we didn't want to start messing around with pitches. It had to do with the integrity of what we believed in, which was presenting soundscapes as a la naturel, as they should be presented.
Not to mention, I'd imagine that affect the timbre as well, so it probably wouldn't sound quite as good.
Exactly, yeah.
Cool, thanks.
I have a science question for you. So with the fish that are making sounds, do you see with like pollution in environments that they're actually starting to mate or make sound? Does it affect the males too? I guess that's kind of the question. Does the male start calling in the winter, and then the female actually will come and mess with behavior that way?
Yeah. So I assume what you're thinking about, a lot of the pollutants are estrogenic. And it's an interesting question. We're starting to think about it more and more, and wondering about using like zebrafish as a test for this. We're seeing that with zebrafish, we also see enhanced hearing sensitivity with estrogen. So it makes it easy that we could put these things in the water, in the zebrafish tank. The effect is there in male hearing as well. The song doesn't seem to be as affected by estrogen, so they're not singing in the winter. As far as we know, actually in winter they're down about 300 feet, so we don't know exactly what they're doing. But there was we have noticed the last few years, and about 4 years ago and I think 5 years ago, and we haven't checked the last couple of years, but the winter fish didn't seem as wintry. Their hearing was a little better. And there's an idea that it might be an El Nino effect, because there was an El Nino back then. It could be pollutants in the water. We don't know what's going on. So it might be that these pollutants are causing them to hear better. So I guess that's a good thing with pollution, but not really. So yeah, it's a great question, and we're very curious about how that's affecting that.
So are there other works, classic works, that are based on animal sounds throughout history?
Yes, there are a great many of them, and some contemporary ones have actually used recordings of The Song of the Whale. George Crumb, the American composer, was experimenting in the 70s with the sounds, particularly of the humpback whale. R. Murray Schafer, another fine American composer, has done a number of environmental works like Once Upon a Windy Night. Messiaen, the French composer, was most famous for his incorporation of birdsong, but no one, to my knowledge, has actually used a sampling keyboard to create whole textures of animals and then to combine them with an orchestra. So I like to think, I may be proved wrong, that we were the first to do that.
So my question is about the orchestra this weekend, and just in general about the orchestra. So you've given us a little sneak peek, which is beautiful, and I'm very excited to hear the full thing. But are you incorporating any marine animals' sounds into the orchestra as well? Just curious.
Only the humpback whale that makes a brief appearance at the end of the first movement. Other than that, we have gorillas, we have elephants, we have... no, I think it's only the whale.
Okay, thank you.
Mm-hmm.
Humpback whales will stop singing when cruise ships come into like fjords and things. They go quiet.
Oh, really?
Yeah, just like the frogs with the plane.
Yeah, yeah.
Do you have plans to do like the next one as far as like with wind and soil sounds, or do you have, what are your next plans for one?
Well, there has been another collaboration since the Great Animal Orchestra. Bernie and I wrote a ballet last year for the Alonzo King Lines Ballet in San Francisco that's currently on tour around the States and will soon be touring Europe as well. And in that, we decided to actually put the balance more towards the soundscapes rather than the music. I just took 5 players, and what they do is very minimal by comparison with the recordings. And the is a wonderful choreographer, Alonzo King. He, I think, has been described as an American treasure. He's won every award that's going. He actually he listened again and again to the recordings that Bernie and I had kind of edited for him, and he really translated into movement, into choreography, a wild boar or bird or whatever it might be. And it's a completely different approach to this, which is more notes-led, it's more music-led, so the other one is more soundscape-led. We haven't yet got into geophony and anthropophony yet, but believe it or not, anthropophony, the idea of the sounds that humans create, has been done enormously by people like John Cage and Edgar Varese, who wrote pieces for vacuum cleaners and carburetors and aeroplanes and klaxons and all sorts of things, and gave an idea of the kind of chaos that we create in particularly in urban landscape. Steve Reich, another fine American composer, has done the same thing. I feel that path has been well trodden, and I'm probably not going to go that way. Geophony is more interesting, wind and rain, volcanoes, some wonderful possibilities. So maybe that's next.
Hi, I'm very excited to see Sunday's show. How has your perception and audition altered through the process of composing, you know, trying to make this composition with sounds, natural sounds and musical sounds? And what do you hope that your work will bring to humankind? How do you expect it to change, you know, have a perspective, people to change their perspective a little bit?
Thank you for the question. I'll answer the last bit first, if I may. Of course, the hope is that people will wonder, as in the good wonder, at the beauty of the natural world. They'll be inspired to go and listen more closely and more carefully. But of course the piece also has an environmental message as well, which is that we need to look after the planet and we need to treasure the incredible diversity of species that we have. There is one very sad movement in this, which I haven't played you, which is about an experience Bernie had recording a beaver whose dam had been blown up by rangers, and he recorded the beaver going round and round singing this mournful tone, the like of which he's recorded beavers before. He said, "I'd never heard anything like that." Its mate and its children had been blown up. And so I think when people have heard the symphony and they hear that, it's actually very moving, not because of anything that I've written, but just simply because of that story. So I hope part of the message is we have an incredible treasure in the world, and it's our duty to preserve the legacy for the next generations. And the first part of your story, how's it changed my perception? Well, it was a revelation. It was, I think the biggest lesson I learned was staying out of the way, which is also something a film composer learns very quickly. Writing film music is not your last statement in what you think music should be. You're actually there to serve something else, which is the picture. And I felt when I listened to these incredible recordings, quite a sense of humility that in fact part of what my job was to provide like a ring setting. I was the surround and the jewel was the soundscape recordings. So a lot of what I was trying to do was to keep out of the way, to let their voices be heard.
Hi. So in listen more? Oh, yeah, okay. Well, in listening to this, it made me wonder sort of what are the ideas about reasons why we humans in our brain is able to feel emotions from sounds, right? I mean, they stir emotions in us, make us feel certain things when we hear music. And I'm just wondering, I guess almost evolutionarily, or I don't know if it's a science question or a music question, but what are ideas about why we have that capacity? And are some of those ideas related to our sort of, to like how we've evolved in nature or anything like that?
Do you want to answer that?
So I know somebody, Karen Cooper, who studies bird song. That's Karen Cooper. I may have a worse answer than you. I don't really know. I do, I think there was, somebody like you might correct me on this, but I think there was a lot of concern about anthropomorphizing animal emotions and things. And it's become less looked down upon, is my sense. Huh?
I mean, our feelings.
Right. But I suspect we get some of our feelings evolutionarily, right? That, I don't. You hear the mournful call of a wolf or something, and I assume that's pulling up some emotional response in other wolves, but I don't know.
The only thing I can add, I don't know the answer. The only thing I can add is that the more, the more the years go on, the more sound pollution I'm aware of. And I think, sorry, slight sore throat, the more aware I am of sounds that we make, of music, of sound pollution, when there's an opportunity to actually hear a pure soundscape, like I did in Borneo, for example, the reason the emotion is so intense is because we're actually reconnecting with what was our primeval state. And it's such a rare thing now because we're surrounded by noise wherever we go. And to actually have the opportunity on a very dark night when there's no planes overhead and you hear the sounds of a forest or whatever it might. I live in the country in England, and sometimes we have these very still nights. It causes a different emotion because I think that's the environment that that we've evolved from, and we are reconnecting with it. That's just my own kind of personal thing.
We've got time for one more question if anybody has a burning desire to know something. Anyone?
So you're saying before that you listened to about 150 different animal recordings. Were there any that really surprised you, that you had no idea that animal made either such a startling sound or a complex sound that may or may not have made it into the orchestra, but just sort of stuck with you when you heard it?
Oh, well, I think they all surprised me. The musician Wren, certainly I'd never heard anything like that in my life. There was one also which shocked me, which you'll hear if you come to hear the symphony, and that's the sound of a gorilla. And there's a wonderful story, which, if I've got a couple of minutes just to tell the story. Bernie was recording in Zimbabwe and was recording gorillas, and because he was recording with headphones on and pointing the microphone in the direction of the baby gorillas, which he thought would be a really good thing to record, and could see the mother somewhere out in the distance, his hearing was entirely in that direction. He couldn't hear that behind him came the daddy gorilla, who came right up to him and lifted him in the air, threw him in the air. He was fortunate to only break a couple of ribs and most of his recording equipment, but he said the cry of that gorilla protecting its young was the most terrifying thing he'd heard in his life, and that features in the fourth movement of the symphony.
Have you ever heard the midshipman fish?
Well, thank you all so much for coming tonight. I hope that you enjoyed this wonderful cafe presentation, and we do hope that you'll be able to join us on Sunday for a concert so that we can hear all of Mr. Blackford's amazing piece of music. Please do fill out surveys if you don't mind. That would be very helpful, and let's give them a warm round of applause. And the museum is open till 9, so feel free to look around and explore. Enjoy. Yes, you can just leave your surveys on the tables, and we'll come around and collect them. Thank you.